This lesson is on the remainder theorem. In the last lesson, we saw how two polynomials, when divided, resulted in another polynomial and a remainder. The remainder has a remarkable property in certain types of division. We will explore this relationship in this first exercise. Well, what we notice in all of these, A, B, C, and D, is that they're all divisible by x plus or minus something. So that means we can use synthetic division. If we want to use long division, we most certainly may. So what I'm going to ask you to do is to pause the video and to go and do synthetic division or long division on A, B, C, and D. So only this first column here, okay? Ignore this stuff for now. And then continue the video, check your answers on A, B, C, and D, and then let's do part 2. All right, so for the first one, A, you should have gotten x minus 6 plus 6 over x minus 2. For B, you should have gotten x plus 5 plus 10 over x minus 7. For C, you should have gotten x plus 5 plus negative 4 over x plus 3. You could also make it 2x plus 5, minus 4 over x plus 3. And then the last one, no remainder, so we just get 3x minus 5. So what does the remainder theorem really talk about? It talks about the second part here, okay? In that we don't have to do all of this long division or synthetic division. We can do a shortcut, and that's what we're going to investigate in this second part, all right? Let's see if you can come up with a relationship. So I want you to do P of 2, P of 7, P of negative 3, and P of negative 4 with the respective quadratics, because they're all quadratics. So that means you're putting in P of x, P of 2. So you're putting whatever numbers in parentheses is your x value. Please find that value. Okay? So again, start the video when you're ready. All right, so hopefully you've got all that algebra done. So for the first one, you should have gotten 6. So the second one, you should have gotten 10. The third one, negative 4. And the fourth one, 0. So why are we connecting these things? So what you should start to notice is that my answer is my remainder. Okay, so P of whatever your root is, okay, should equal your remainder. Well, the most important piece of this is most of the time they don't ask you questions about what's the remainder. They ask you, is either this a root or is this a factor? So to know if something is a factor, we're going to look at the last one because we got 0. A 0 remainder means that x plus 4 is a factor of that polynomial, or quadratic in this case. Okay? So because we got no remainder, it goes in evenly, that means it's a factor. Well, then that means negative 4 is a root. Okay? If we graphed it, we would see it goes through the x-axis and negative 4. Well, I didn't have to do all of this to find out if x plus 4 is a factor or negative 4 is a root algebraically. I could have just plugged in the root's value into the polynomial on top, the one I'm dividing it into, and if I get a 0, then yes, that's a root, or x plus 4 is a factor. If I don't get 0, if I get negative 4, 10, or 6, or any other number, then it's not a factor or not a root, depending on what the question is asking. Okay? So my advice right now is pause the video and really think about that relationship. We have talked about that all year, about factors and roots, Well, now we're looking at how to tell if something is a factor or a root algebraically. We know how to do it graphically, but now we need to know how to do it algebraically. Okay? All right, so the remainder theorem says when the polynomial p of x is divided by the linear factor x minus a, then the remainder will always be p of a. Okay? And that's what we did on the last page. So in exercise 2, if the ratio or division was placed in the form of given, where q of x is a linear function, then which of the following is the value of r? So again, they're asking us just for the remainder. They're not asking us for what quantity divides into it evenly. They're asking us for the remainder. So we can just take this and find p of a. Well, what's a? A is 9. So we're going to plug 9 into that quadratic. Okay, we're going to plug 9 into here. So 9 squared minus 11 times 9 plus 22. So if you can't do that quickly in your head, grab your calculator. So your answer should be 4. So this is your remainder. So since it doesn't equal 0, x minus 9 does not go into that polynomial or quadratic evenly. So it's not a factor. So your answer is choice 4. Okay? So in the past, the remainder theorem was used primarily to aid in evaluating polynomials. These days, it is the primary justification for telling if a linear expression is a factor of a polynomial. It tells us if a linear expression is a factor of the polynomial. So if you get f of x, or if f of x is a polynomial and you get f of c equals 0, then x minus c is a factor of f of x. If x minus c is a factor of f of x, then you know f of c equals 0. So vice versa. If you plug it in and you get 0, then you know it's a factor. If you have the factor and you plug in the c value and you get 0, you know it's a root. Vice versa. They are directly related with each other. Okay? All right. So, can you go and try exercise 3? Don't use long division or synthetic division. Use this idea that we've been talking about with p of c and x minus c, and if you get 0, it is a factor, or talking about roots, whichever one they're asking you. Okay? So try this. So hopefully you got for part A an answer of 0. For part B, you got an answer of 3. So we know in part A, x minus 3 is a factor of p of x because the remainder would be 0. And in part B, no, x plus 5 is not a factor of p of x because the remainder would be 3. We did not have to do the long division or the synthetic division. We just had to use our fact of using f of c equals 0, so that means it is a factor, and if f of c doesn't equal 0, then it isn't a factor. Okay? All right, let's try 2 more, and then we will make our life a little bit more difficult. Okay? So why don't you try, interesting, I have D and C backwards on the next page, so why don't you try C and D, and then we'll do exercise 4 together. Continue the video when you're ready to check your answers for C and D. All right, here's my answers to C and D, or D and C, and go ahead and pause and make sure you have the correct work down and that your answers match. If you have any questions, please don't hesitate to ask in class tomorrow. The last one, go ahead and read it. See if you can come up with a plan. If you can, go ahead and try it, and then start the video. If not, you have no clue. Hopefully that's not the case, but we will do it together. Hopefully the plan you came up with was using what we've done above. So if I know this is a factor, then I know the root is 4, so I'm going to use p of 4, and it has to equal 4 squared plus, I don't know k, I might use a different color, times 4 minus 52. If it is to be a factor, what does this have to equal? Hopefully you've said 0. So now I need to do the math. So 4 squared is 16 plus 4k minus 52 has to equal 0. So I can do my math, combine like terms. 16 minus 52 is 36. So I have negative 36 plus 4k equals 0. And I'm solving for k. So add 36. So 4k equals 36. Divide by 4. So k equals 9. So you could plug 9 back in here, plug this in, it better equal 0. You could plug 9 in for k, you could graph it, make sure that 4 is one of the roots, therefore x minus 4 is a factor. You could take this quadratic, divide either using synthetic or long by x minus 4, and you should get a remainder of 0. Okay? All right, good luck with this. If you have any questions, please don't hesitate to ask in class.